Where'd you find this?
For section 2.2, doing geometric proofs. The learning targets both involve congruence, segment and angle congruence. There's a definite theme to the examples in this lesson. So let's dig in. Before you can start writing proofs out, geometric proofs, you need to know some different properties that we can use in the context of geometric figures. So we've talked about these three properties in terms of algebra. In terms of geometry, reflexive property basically just says that a segment length is equal to the length of the same segment. All things are equal to themselves. The symmetric property says is the property that allows us to flip around an equal sign. So we know that if AB is equal to CD, that means that CD would be equal to AB. It allows us to have symmetry around an equal sign. And the transitive property is the thing that says that if two segments are equal or congruent to the same segment, then that means they have to be equal or congruent to each other. So if AB is equal to CD and EF is equal to CD, that means that AB and EF must be equal as well. In terms of angles, the reflexive property, the symmetric property, and the transitive property work exactly the same way. The only difference is now we're talking about the measure of angles rather than the measure or the length of segments. So again, two angles are both equal to angle 2. That means they must be equal to each other. So these geometric proofs, again, they're always going to start with a couple of points, and then they're going to tell you where should you be trying to end up. So for this example, it's a really short proof. We are told that angle 1 and angle 2 are equal, angle 2 and angle 3 are equal. So prove angle 1 is equal to the measure of angle 3. Start with your two givens. Usually you want to start with the givens. So now we've established that angle 1 is congruent to angle 2, and that angle 3 is congruent to angle 2. So that means, how can we end up here that angle 1 and angle 3 are equal? Well, when two things are both equal to the same thing, they have to be equal to each other, and that is the transitive property. This is a really simple one, and there's only one step you really need to justify, but it is a good example of that. We won't just use properties. Sometimes we'll use theorems or definitions to justify or to be the reason in the proof. A theorem is a conjecture that's been proven to be true already, and definitions we can also use as well. So one definition that you will use is the definition of a midpoint. Midpoint is the point halfway between the endpoints of a segment. So we use the definition of a midpoint in a proof if we know that something is a midpoint, like in this example, x is a midpoint of a, b. We use it to then be able to say that two parts are equal. The two halves have to be equal. So we use the definition of a midpoint to say that if we know this, we can make this conclusion. Or if we know this, that two halves of a segment are equal, we could use it to say that x must be the midpoint if we have the first part, that those two parts are equal. So we can go both directions here with this midpoint here. Okay, so an example of how that is used. Example 2, given a couple of things, that B is the midpoint of AC, and that C is the midpoint of BD, then we want to be able to end up at the point where we say that AB is congruent to CD. So again, start with your givens. So if I know B is the midpoint of AC, then if I'm given this, I should have to use it somewhere. It would make sense that I'm going to use this information. So what can I do with the fact that B is the midpoint of AC? I can say, based on the midpoint theorem, that the two parts of AC must be congruent or equal, that AB must be congruent to BC. And I can do that because I know that B is a midpoint. So I've used the midpoint theorem. So one thing that people miss a lot of in this whole concept is that if you're given a piece of information, odds are you're going to use it. So this first given gives me this step here, that those two parts are congruent. So then with the next given, that C is the midpoint of BD, it would make sense that I would take the midpoint, that key word, and use that to say that the two parts of BD are congruent. BC is congruent to CD. Again, that's midpoint theorem. And now it just so happens I see two different things that are both congruent to BC. And it's the two things I want to end up being able to say are congruent to each other. So using each of these two givens has set me up really nicely for transitive property. AB and CD are both congruent to BC, so they must be congruent to each other. We've got a couple other definitions or theorems that we'll use. You guys know already that an angle bisector is a ray that cuts an angle into two equal pieces. Basically, it's just like a midpoint, but for angles. So if we see this word bisects an angle, then that tells us the two smaller angles must be congruent. Vertical angles, if we know two angles are vertical angles, that is, they are across the intersection from each other, then they are congruent. These both are things that when we see these keywords, angle bisector or vertical angles, that they set us up for a step in a proof. So it's really important that you get used to looking for these keywords. Now, when I look at example 3, I want just to see what we can do with some things. This is a fairly long one, but we know our first 3 reasons. They're all things that are given to us, so we should at least have that much down. Then we should be able to fill in our end result because that's what we're trying to prove in the long run. So I want for you to just see what you can do with this. It says right here, one of the givens is that FB bisects AFC. So what conclusion can you draw down here in step 4 because of that being a bisector? What can you say about these two angles that make up AFC? What does FD bisecting CFE allow you to do in step 5? What does that thing bisecting do to these two angles? What can you say about the result of an angle bisector? After you've set those up, then see if you can maybe find a place to use the transitive property. Just give it a shot. We'll talk it over tomorrow in class. Thank you.